So, hi everyone. So, good evening all. So, first of all, let me know whether audio and video everything is clear. So, first of all, let me know whether audio and video everything is clear. So, if it is clear, please give some comment in chat box here. Right. Okay, if you confirm whether audio and video is clear, then we can proceed. Let me know whether audio and video is everything clear. Yes. Okay. So, okay then. I hope everything is clear. So, if it is not clear, please let me know through chat box. Right? Okay. Okay. So, from today onwards, I am going to take up the problems regarding EC branch here. So, only for EC branch. Understood? Okay. So, today the topic is uniform plane waves. So, today we are going to solve the problems based on uniform plane waves. Based on uniform plane waves. Right. Okay. Okay. So, we will take up some problems and we try to solve those problems based on uniform plane waves. Right. Okay. Okay. So, first problem, write down the first problem. The electric field today we are going to solve the problems based on in a lossless medium here, lossless medium. Right. See, what do you mean by lossless medium? So, lossless medium means the conductivity of that medium is equal to 0 and epsilon r and mu r values must be what? Must be real. So, then we can call that medium as lossless medium. Right. So, today we try to solve the problems in lossless medium. Right. Okay. The propagation of uniform plane waves in lossless medium. So, what is the condition for lossless medium here? The conductivity of that medium is equal to 0 and epsilon r and mu r values must be what? Must be real quantities. So, then we can treat that medium as lossless medium. Right? Okay. Okay. So, first of all, write down the problem here. So, the electric field of an plane wave propagating in a lossless non-magnetic medium with epsilon r is equal to 2.56 is given by E bar is equal to 20 into cos of 6 pi into 10 to the power of 90 minus beta z ay cap volt per meter. So, then determine frequency of the wave, phase velocity of the wave, wavelength of the wave, phase constant beta and intrinsic impedance of the medium eta. So, these are the parameters you have to determine here. So, what they have given? Who's that here? Abul Tul here. He has written something, I don't understand. Okay. Right. So see here. So what they have given here? So they have given that the electric field of an plane wave propagating. Plane wave means you have to understood that it is electromagnetic wave. So plane electromagnetic wave propagating in a lossless, I have already told what do you mean by lossless medium. So lossless non-magnetic medium with epsilon r is equal to what? Is equal to 2.56 is given by E bar is equal to what? Is given by E bar is equal to 20 into cos of 6 pi into 10 power 90 minus beta z ay cap volt per meter. So then you have to determine the frequency of the wave, phase velocity of the wave, and then wavelength and phase constant of the wave, and then you have to determine the intrinsic impedance eta of the medium. Okay, so these are the different parameters that you have to determine, right? Okay. So now so what they have given? The expression for electric field. So they have given the expression for electric field E bar is equal to what? 20 into cos of 6 pi into 10 to the power of 9t minus beta z ay cap volt per meter. And also they have given the relative permittivity of the medium, that is epsilon r is equal to 2.56. So one more thing you have to observe here is they have given that the medium is non-magnetic medium. So non-magnetic medium means the relative permeability of that medium is equal to what? Is equal to 1. Okay, so since the medium is non-magnetic, you can consider mu r is equal to 1 since the medium given is non-magnetic medium. Okay, and hence mu r is equal to 1, right? Okay. So now see here, so they have given the expression for the electric field. So 20 into cos of 6 pi into 10 to the power of 90 minus beta z. So this is 6 pi into 10 power 9 will represent what? Will represent omega. Yes or no? Okay. This represents omega. So from here omega equal to what? Omega is equal to what you are getting here? 6 pi into 10 to the power of 9. Right. And omega I can write it as what? 2 pi into f, which is equal to 6 pi into 10 to the power of 9. So from here you can easily determine the frequency. So that is 2 pi 1s and here 2 pi 3s. So therefore frequency f is equal to what? 3 into 10 to the power of 9 Hz, or you can write it as what? Simply 3 gigahertz. So this is the frequency of the wave here, right? Okay. So this is just like what? 20 into cos of omega t minus beta z. So here omega value is nothing but 6 pi into 10 to the power of 9 radian per second. So from this you can easily determine the frequency of the wave. So that is f is equal to 3 gigahertz. See here one more thing. By seeing this expression here, from this expression what we can conclude here? See, the electric field is pointing in which direction? It is pointing in ay cap direction, and it is propagating in which direction? It is propagating in positive z direction. Yes or no here? See how you can say it is propagating in positive z direction means, see here it is just like a 20 into cos of omega t minus beta z, right? So ay cap volt per meter. Okay, so now if you observe here, the polarity before omega t and the polarity before beta z, both are having what? Opposite polarity. Yes or no? Here the polarity before omega t is nothing but plus, and the polarity before beta z is nothing but minus. So if the polarity before omega t and the polarity before beta z, if they are having opposite polarity here, then in that case we can say the wave is propagating in positive direction, that means positive z direction. Understood? So in the same problem, suppose if they have given 20 into cos of minus omega t plus beta z. Suppose they have given like this here. So here also the polarity before omega t is minus and the polarity before beta z is plus. So you can simply say this wave is propagating in which direction? It is propagating in positive z direction. Or if they have given like this, let us say 20 into cos of omega t plus beta z, if they have given like this here. So then if you observe, the polarity before omega t is plus and the polarity before beta z is also plus. So if the polarity is same here, if the polarity is same, then we can say the wave is propagating in negative z direction. Then you have to say wave is propagating in negative z direction. So one thing remember, so depending upon the polarity before omega t and polarity before beta z, we can judge the direction of wave propagation. Understood? So if they are having opposite polarity, the wave is going to propagate in the positive direction. If both are having the same polarity, then the wave is going to propagate in negative direction. So that's what you have to keep in mind, right? Okay. 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 So here we have determined the frequency of the wave. Next, what they are asking here? They are asking phase velocity of the wave, right? So what is the phase velocity of the wave here? Phase velocity. How to determine the phase velocity of the wave? So the phase velocity of the wave is equal to what? Is equal to, I can write it as c by square root of what? Square root of mu r into epsilon r. So this is the phase velocity of the wave in a lossless medium. Yes or no? Okay. So that is nothing but c by square root of mu r epsilon r. So now here, since the medium is non-magnetic, mu r value is equal to what? Mu r value is equal to 1. Yes or no? So just replace mu r with 1. And epsilon r value they have given as 2.56 here. They have given it as 2.56. And we know c value. What is c value here? C value is nothing but 3 into 10 to the power of 8 meters per second. Right? Okay? Okay. Yeah. So if you do this, what you are going to get? So you are going to get, wait here. Wait here, 1 minute, I will get the calci, right? Okay. 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 So you are going to get 3 divided by square root of 2.56. So you will get here 1.875 into 10 to the power of 8 meters per second. So this is the phase velocity of the wave, right? Okay. Okay. So c value is 3 into 10 to the power of 8 divided by square root of 2.56 is equal to 1.875 into 10 to the power of 8 meters per second. So this is the phase velocity of the wave, right? Okay. So next what they are asking? So we have determined frequency, we have determined phase velocity. They are asking lambda, right? So how we can determine lambda here? So lambda, that is wavelength of the wave. So lambda into f is equal to what? Is equal to phase velocity of the wave. So therefore lambda is equal to what? Lambda is equal to phase velocity divided by frequency. So here phase velocity we have already determined here. So what is phase velocity we got? We got it as 1.875 into 10 to the power of 8. And what is the frequency of the wave? Is nothing but 3 gigahertz. So that means 3 into 10 to the power of 9. So calculate this one here. Calculate this one. What you are going to get? So 1.875 divided by 3. So here 10 power 8 and here 10 power 8 will get cancelled, right? Okay. So you will get 0.0625 here, right? You will get 0.0625 meters. So this is the wavelength of the wave. Okay. So this is the value of the wavelength. So that is 0.0625. So next, what they are asking here? So next they are asking phase constant beta. So what is phase constant beta here? What is phase constant beta? So we know that beta is equal to what? Beta is equal to, so beta is equal to 2 pi by lambda. We know this one, yes or no? So the phase constant beta is equal to 2 pi by lambda. So what do you mean by phase constant here? So what this phase constant will tell you? So it tells you how the phase of the wave, that is how the spatial phase of the wave changes for every meter. So what it is going to tell you? How the spatial phase of the wave changes for every meter, how the phase of the wave changes for every meter as the wave propagates in a medium, as the wave propagates in a medium. So it represents the change in phase per meter here, right? Okay, so the units of beta is nothing but radian per meter. Okay, so how the spatial phase of the wave changes for every meter as the wave propagates in a medium, or how the phase of the wave changes per meter as the wave propagates in a medium. So that is given by phase constant beta. See here, whenever, if you consider a wave, so from here to here, what is the change in phase here? The change in phase from here to here is nothing but what? Is nothing but 2 pi radians. And what is the length, or what is the distance from here to here? Is nothing but what? Is nothing but wavelength lambda, right? Okay, so over lambda meters, the change in phase is nothing but 2 pi radians. So over lambda meters, the change in phase is how much here? Is nothing but 2 pi radians, right? Then what is the change in phase per meter? So whenever the wave has propagated over lambda meters, the change in phase is going to be 2 pi radians. Then what is the change in phase per meter here? Is nothing but 2 pi by lambda. So the change in phase per meter is called as beta, that is phase constant. Understood? Okay, so over lambda meters, the change in phase is 2 pi radians. Then change in phase per meter, is called as what? Is called as beta, which is equal to what? Which is equal to 2 pi by lambda. Over lambda meters, the change in phase is 2 pi radians. So per meter, what is the change in phase here? So that is nothing but 2 pi by lambda. So beta is equal to 2 pi by lambda radian per meter, right? Okay. So now so we can get one more relation here. See here, so beta is equal to 2 pi by lambda, right? Now here I am multiplying with f, and here also I am multiplying with f, that is frequency. So 2 pi f is nothing but what? Omega, and lambda f is nothing but what? Phase velocity. So beta can also be written as what? Written as omega by phase velocity, or I can say the phase velocity. The phase velocity can be written as what? Can be written as ratio of omega by beta. Understood? Okay, so omega by beta meters per second, right? Okay. So now in this problem we have to determine now beta value, right? Okay, so beta, so next is beta. So beta is equal to what? Is equal to 2 pi by lambda, which is equal to what? Which is equal to 2 pi divided by, we have already determined lambda value. So what is lambda value here? Tell me. What is lambda value here? Tell me. So here lambda value is nothing but 0.0625 meters. 0.0625 meters. So substitute that. So lambda value is 0.0625. So this is equivalent to what? Tell me what you are going to get. So 2 pi divided by 0.0625. Okay. So you are going to get 100.53 radian per meter. So this is phase constant beta value, right? Okay. So next, what they are asking here? Next. So beta we have determined. So next they are asking intrinsic impedance of the medium, that is eta. Okay, so what is eta value here? Intrinsic impedance. So what is the expression for intrinsic impedance of the medium here for a lossless medium? For a lossless medium, what is the expression for the intrinsic impedance? Tell me. So the intrinsic impedance is nothing but what? It is nothing but the ratio of what? The ratio of E to H ratio. It is nothing but E by H ratio, which is called as intrinsic impedance of the medium. And we are dealing with the lossless medium. For lossless medium, intrinsic impedance eta is equal to what? Square root of mu by epsilon is equal to square root of mu by epsilon. Right? Okay. Yeah. So now this is square root of mu by epsilon. I can write it as what? Mu I can write it as mu naught into mu r divided by epsilon. I can write it as epsilon naught into epsilon r. So now here square root of mu naught by epsilon naught is nothing but eta naught. So I can represent it as eta naught here, right? So where this eta naught represents what? Represents the intrinsic impedance of free space, right? So square root of mu naught by epsilon naught, I can write it as eta naught. Next, what is left out here? Next is square root of mu r by epsilon r. So this is for eta naught is for what? Intrinsic impedance of free space or air medium or vacuum, right? Okay. So what is that value here? What is the value of eta naught? So we know that the value of intrinsic impedance for free space is nothing but what? 120 pi ohm, or it is approximately 377 ohm. Okay, so this eta naught value is approximately 120 pi ohm. So into what? Into square root of mu r divided by epsilon r. So now here mu r value they have given it as what here? Non-magnetic medium. Non-magnetic medium means mu r value is equal to 1, right? And epsilon r value. So what is epsilon r value they have given? So epsilon r value they have given as a 2.56, right? So they have given epsilon r value as 2.56 here. 2.56. Okay. So from here what you are going to get? Intrinsic impedance eta is equal to 120 pi divided by what? Divided by square root of 2.56. Okay, so if you do this, what you are going to get? Tell me here. So 120 pi divided by square root of 2.56. So you will get a 253.619 here. 235, right? So 235.619 ohms, right? So this is the intrinsic impedance value you are going to get. Okay. Right. So we have determined the frequency of the wave, phase velocity we have determined, lambda value we have determined, beta value we have determined, and also we have determined intrinsic impedance of the medium. So these are the parameters that we have determined here, right? Okay. So we will move on to next problem here. Next problem. Okay. So next problem. In a lossless medium, the electric field and H field of an is given by E bar is equal to 500 into cos of 10 to the power of 7 t minus beta z ax cap volt per meter, and H field H bar is equal to 1.1 into cos of 10 to the power of 7 t minus beta z ay cap volt per meter. If the wave is traveling, propagating with a phase velocity of Vp is equal to what? Is equal to 0.5 times of C, right? 0.5 times of C. Then determine epsilon r, mu r, beta, lambda and eta. Okay. So this is next problem. So note down this problem here. So in a lossless medium, the electric field and magnetic field of an electromagnetic wave is given by E bar is equal to 500 into cos of 10 power 7 t minus beta z ax cap volt per meter, and H field is given by 1.1 into cos of 10 power 7 t minus beta z ay cap volt per meter, right? If the wave is propagating with a phase velocity of Vp, phase velocity of Vp is equal to what? Is equal to 0.5 times of C. So the phase velocity here is half of what? Half of the velocity of light. So then in that case determine epsilon r value, mu r value, phase constant beta value and lambda value and intrinsic impedance eta value, right? Okay, so you have to determine all these values here. So how we can determine here? Tell me. So take this, I am copying this electric field and magnetic field expressions, right? Okay, so these are the electric field and magnetic field expressions of an electromagnetic wave they have given, right? So first of all you have to observe that the electric field is pointing in which direction? It is pointing in ax cap direction, and the wave is propagating in which direction? Positive z direction, because already I have told this is nothing but what? This is nothing but omega. So this is nothing but omega, right? So if the polarity before omega t and the polarity before beta z both are having opposite polarity, so which means the wave is propagating in positive direction. That means it is propagating in positive z direction. Understood? So that's what you have to understand, right? Okay. Now You have to determine what? You have to determine epsilon r value, you have to determine epsilon r value, and also you have to determine mu r value. Okay, first we try to determine these two things here. So then we can determine beta value, and then you can determine lambda value, and then you can determine eta value also, right? Okay, okay. So see here. So first we try to determine, we know the intrinsic impedance expression here. For intrinsic impedance, we know that the intrinsic impedance of a lossless medium eta is equal to what? Is equal to square root of mu by epsilon. Yes or no? So where eta is nothing but what here? It is nothing but the ratio of E to H. The ratio of E to H. Okay, so the ratio of E by H is nothing but intrinsic impedance of the medium, which is equal to what? Square root of mu by epsilon. Right. Now here, what is the amplitude of the electric field they have given? The amplitude of the electric field they have given as 500, and the amplitude of magnetic field they have given it as what? 1.1. Okay, so 500 divided by 1.1 is nothing but what? Is nothing but the intrinsic impedance of the medium. Yes or no? Okay, so here 500 divided by what? Divided by 1.1. This is equal to what? This is equal to intrinsic impedance of the medium, which is equal to what? Which is equal to square root of mu by epsilon. I can write it as mu naught mu r divided by what? Epsilon naught epsilon r. So this is equal to what? So square root of mu naught by epsilon naught represents the intrinsic impedance of free space. So which is nothing but I can write it as 120 pi. Yes or no? So this is 120 pi is nothing but intrinsic impedance of free space here. Right. So 120 pi into what is left out here? Square root of mu r by epsilon r. Okay. So from here I can write therefore square root of mu r by epsilon r here. Square root of mu r by epsilon r is equal to what? Is equal to 500 divided by 1.1 into 120 pi. Into 120 pi. Okay. Okay. So this is the expression I got, that is square root of mu r by epsilon r. I got it as 500 by 1.1 into 120 pi. So I am keeping this as equation 1 here. I am keeping this as equation 1. Right. Next, what they have given here in the problem, they have given that the phase velocity of the wave, is equal to what? Is equal to 0.5 times of c. So this is what they have given. Right. Okay, and we know the expression for phase velocity here. So what is the expression for phase velocity here? So the expression for phase velocity is equal to what? C by square root of mu r by epsilon r. Yes or no? C by square root of mu r into epsilon r. So this is the expression for phase velocity. We know this one. Right. Now here they have given that the phase velocity is 0.5 times of c. So 0.5 times of c is equal to what? C by square root of mu r epsilon r. Right. Okay. Now what happens here? Here c will get cancelled. So you are going to get what? Square root of mu r into epsilon r is equal to what? Is equal to 1 by 0.5, that is nothing but 2. So this value is equal to 2. So this is what you are going to get. Right. So let us say this is equation number 2. Let us say this is equation number 2. Okay. Okay. Yeah. So from equation 1 and equation 2, you can determine what? You can determine mu r and epsilon r values. Right. So how we can determine here? See here, if you multiply 1 and 2 here, if you multiply 1 and 2, so if you multiply 1 and 2, so what you are going to get? So square root of mu r by epsilon r, square root of mu r by epsilon r into what? Into square root of mu r into epsilon r is equal to what? Is equal to 500 divided by what? 1.1 into 120 pi. So this multiplied by what? This multiplied by, so this value square root of mu r epsilon r value is 2. Right. Okay. Okay. Yeah. So now see here root epsilon r and here root epsilon r will get cancelled. So therefore you are going to get what? You are going to get mu r value. So mu r is equal to what? Mu r is equal to, so 500 into 2 is nothing but 1000 divided by 120 pi into 1.1. So what is this value here? Tell me. So what is this value? (120 pi to 1.1), right? So you will get a 2.41 here. You will get 2.41. So this is mu r value. This is the value of relative permeability, right? Okay. Okay. So next we have to determine epsilon r value. So how we can determine epsilon r value here? So if you do 2 divided by 1 here, if you do 2 divided by 1, so that is nothing but, so second equation is nothing but square root of mu r epsilon r, this divided by 1, so that is square root of mu r epsilon r. So if you do 2 divided by 1, then what you are going to get? You are going to get epsilon r value, yes or no? So that is square root of mu r epsilon r divided by square root of mu r by epsilon r. Okay, so here root mu r and here root mu r will get cancelled. So here you are going to get epsilon r value. So this is equal to what? This is equal to 2 divided by what? 2 divided by 500 divided by 1.1 into 120 pi, right? So do this one here, do this one. You are going to get epsilon r value, right? So therefore epsilon r is equal to what? Is equal to, so what you are going to get here, tell me? So 2 into 1.1 into 120 pi divided by 500. Okay, so epsilon r value you are going to get 1.658. Okay. Okay, so you will get epsilon r value as 1.658, right? So this is the value of epsilon r. So we got values of epsilon r as well as what? Mu r, right? So next here what they are asking here? They are asking phase constant here. They are asking phase constant, right? So what is phase constant here? So phase constant beta is equal to so 2 pi by lambda, yes or no? In this manner I can write 2 pi by lambda, or I can write this as what? So if I multiply with f here and f here, so I can write it as what? See here, I am multiplying here with f numerator and denominator also with f. So then I can write it as what? 2 pi f is nothing but omega divided by lambda into f is nothing but phase velocity of the wave. Understood? So this again I can write it as omega divided by what? The phase velocity of the wave. I can represent it as what here? The phase velocity of the wave in a lossless medium is equal to what? C by square root of mu r epsilon r, right? So replace the phase velocity with what? C by square root of mu r epsilon r. So then you are going to get what? Omega by c into square root of mu r epsilon r. So in this manner I can represent beta r, yes or no? Okay, okay. So therefore beta I can represent it as omega by c into square root of mu r epsilon r. Now here what is omega value here? What is omega value? So here the omega value is nothing but 10 power 7. They have given omega value as 10 power 7, right? Okay, okay, substitute here, substitute that. So 10 power 7 divided by c is nothing but 3 into 10 power 8 into what? Into square root of mu r epsilon r, right? So what is mu r value here? Okay, otherwise they have given already phase velocity na, so you can directly substitute that here, you can directly substitute that. But remember that we can write this beta, we can write this beta as omega by c into square root of mu r epsilon r. So this relation is also very, very important here. So while solving the problems, this relation is going to be very much helpful, right? Okay, so that's why I have derived that relation. Okay, now here I can represent this beta as what? Omega by phase velocity, omega by phase velocity. So here omega by the phase velocity, what they have given here? The phase velocity they have already given it as a 0.5 times of what? 0.5 times of c. Understood? Okay, now directly you can substitute the values. So omega is nothing but 10 to the power of 7 divided by 0.5 into c is nothing but what? 3 into 10 to the power of 8. Okay, so from here you can determine beta value, right? Right. So now see here 10 power 7 and here 10 power 7 will get cancelled, right? So what you are going to get, tell me? So 0.5 into 10 is nothing but 5. So 5 into 3, 15. So 1 by 15. So 1 divided by 15. So you will get a 0.067 here, 0.067 radian per meter. So this is beta value, right? Okay. So in most of the problems, this relation is going to be very much helpful here. So that's why I have derived this relation also, right? Okay. Okay, so we have determined beta also. So then they have asked lambda. So we know that lambda into f is equal to what? Is equal to phase velocity. So therefore lambda is equal to what? Lambda is equal to phase velocity divided by frequency, right? Okay, so this is equal to phase velocity is nothing but what? 0.5 times of c. So divided by frequency. So what is frequency here? Omega is 10 power 7. Omega is equal to 10 to the power of 7. So therefore frequency is equal to what? 10 to the power of 7 divided by 2 pi, right? So substitute these values here. What you are going to get? So here 0.5. So c value is 3 into 10 to the power of 8 and frequency is 10 to the power of 7 divided by 2 pi. So that means you are going to get 2 pi here, right? Okay. Okay. So if you do this, what you are going to get? Tell me. What is the answer you are going to get? So here 10 power 7 and here 10 power 7 will get cancelled. So 0.5 into 10 you are going to get 5. 5 into 3 15. 15 into 2 30. 30 into pi. So that is you are going to get 30 pi, right? 0.5 10 5 3s are 15 15 to 30 30 pi. Okay, so you are going to get 30 pi meters, right? So that means 30 pi, or you can write it as 94.247 meters. So this is wavelength here, this is lambda value, right? Okay. So we have determined lambda value and we have determined epsilon r value, we have determined mu r value, we have determined beta value, right? Okay. So I think we have determined all the values here, right? Okay. So epsilon r value we have determined, mu r also determined, beta also determined, lambda also determined, eta value is also determined, right? Okay. So with this we have completed this problem here. With this we have completed this problem, right? So next problem here, next problem. So write down, in air medium, in air medium, E field and H field of an plane electromagnetic wave is given by E bar is equal to 120 pi into cos of 2 pi into 10 to the power of 8t minus 2 pi by 3 into z ax cap volt per meter, and H field is equal to 1 into cos of 2 pi into 10 to the power of 8t minus 2 pi by 3 into z ay cap ampere per meter. Okay. Now, due to heavy rain, the medium properties epsilon r has changed from 1 to 9 and mu r has changed from 1 to 16. Then by assuming that the amplitude of electric field remains same, write down the expressions for nu E and H fields, right? Okay. Okay, so see here, this is the question they are asking. What is the question they have given here is in air medium, electric field and magnetic field of an plane electromagnetic wave is given by E bar is equal to 120 pi into cos of 2 pi into 10 power 8t minus 2 pi by 3 into z ax cap volt per meter. So that means here the electric field is pointing in ax cap direction and the wave is propagating in positive z direction. So 2 pi into 10 power 8 is nothing but omega value, right? So now this wave is propagating in which direction here? Positive z direction, and the electric field is pointing in ax cap direction. And H field they have given it as 1 into cos of 2 pi into 10 to the power of 8. So this is omega value. Okay, 2 pi into 10 power 8 t minus 2 pi by 3 into z ay cap ampere per meter. So the magnetic field is pointing in which direction here? A y direction, positive y direction, and the wave is propagating in which direction? Positive z direction. Understood? Okay. Okay. So these are the fields they have given in which medium? In air medium. In air medium, the E field and H field of an electromagnetic wave they have given. Now, due to heavy rain, now in this medium here, what they are saying here is due to heavy rain in the medium, what happens is the medium properties epsilon r has changed from 1 to 9. So that means in air medium, the relative permittivity of the medium is nothing but 1. Now, due to heavy rain in this medium, the relative permittivity has changed from 1 to what? 1 to 9. Okay, 1 to 9. And similarly, mu r, that is relative permeability of the medium, has changed from where to where? Has changed from 1 to 16. In air medium, the relative permeability is 1. Now, due to heavy rain, this mu r value has changed to 16. Understood? So that's what you have to understand. Then by assuming that the amplitude of electric field remains same, by assuming that the amplitude of electric field remains same, write down the expressions for new electric and magnetic fields. Write down the expressions for new electric and magnetic fields. So that means due to heavy rain here, due to heavy rain in this medium, the medium properties has been changed. So that is epsilon r value has changed from 1 to 9 and mu r value has changed from 1 to 16. Okay, so once the medium properties has changed, then you have to write the expressions for electric and magnetic fields. Right? Okay. Okay. Yeah. And here, what is the condition they are saying? They are saying that assuming that amplitude of electric field is remaining what? Is remaining same. Assume that the amplitude of electric field is remaining same. Okay, so by assuming this, you have to write the expressions for electric and magnetic fields. Right? Okay. Okay. Yeah. So now see here, I am copying this expressions here, electric field and magnetic field expressions. Right? Okay. Okay. So now what they are saying here, due to heavy rain, this is the fields they have given in air medium. So now due to heavy rain, what happens here? So epsilon r value becomes what? Becomes 9. Yes or no? It has changed from 1 to 9. In air medium, its value is 1. Now due to heavy rain, epsilon r value has changed to 9 and mu r value has changed to 16. Understood? Now in this medium, you have to represent the electric and magnetic field expressions. Right? Okay. And they are saying one more thing, that is assume that the amplitude of electric field. They are saying that assume the amplitude of electric field will remain same. Understood? Okay. Okay. Yeah. See here, whenever the medium properties changes here, so then the parameters which are depending upon the medium properties are also going to change. Right? Now this omega represents omega is nothing but the frequency in radian per second. Okay, so this frequency is not going to change here. The frequency will always remain same. The frequency is not going to depend upon the medium parameters. Understood? Okay, so the frequency omega will remain same. And here this 2 pi by 3 is nothing but what? Is nothing but phase constant, that is beta. This is nothing but 2 pi by 3 is nothing but beta. Right? Phase constant. So phase constant beta is equal to what? Is equal to omega by c into what? Square root of mu r epsilon r. So that means beta is depending upon what? Beta is depending upon the medium properties, that is mu r and epsilon r values. So and hence this beta value is going to change if mu r and epsilon r are changing. If mu r and epsilon r changes, then beta will also going to change. Right? Okay. So one thing we can confirm that this beta is going to change. Right? Next, intrinsic impedance of the medium here. If you observe intrinsic impedance of the medium, so intrinsic impedance of the medium is equal to what? For lossless medium, eta naught into what? Square root of mu r by epsilon r. Right? So this intrinsic impedance of the medium is also depending upon what? It is also depending upon mu r and epsilon r values. So that means whenever the medium properties changes, that is whenever mu value and epsilon value has been changed, understood, then eta value is also going to change. right? So next, what is the another parameter that is going to depend upon the medium properties here? So that is nothing but phase velocity here. If you consider phase velocity, so the phase velocity is equal to what? C by square root of, for lossless medium I am writing, okay, for lossless medium the phase velocity is equal to what? C by square root of mu r epsilon r. Now here, if mu r epsilon r changes, then also the phase velocity is going to change, okay. So if the medium properties changes, then which parameters are going to affect here? Beta is going to get affected, eta is going to get affected, and phase velocity is also going to get affected. Understood? Okay, okay. So these things you have to keep in mind, right? So now, due to this heavy rain, the medium properties has changed. Now in this medium you have to write down the expressions for electric field and magnetic field, right? Okay, and they are saying that assume amplitude of electric field remains same. So they are saying that assume amplitude of electric field remains same, right? Okay, okay. So now what you are going to get, tell me. So here electric field E bar is equal to what? Is equal to, so they are saying that its amplitude will remain same, that is 120 pi. So 120 pi into cos of, so omega is not going to change, yes or no? So the frequency will remain same, so that is 2 pi into 10 to the power of 8 t minus, now beta is going to change, yes or no? Whenever medium properties changes, beta is going to change. So now in this case, what is beta value? Beta is equal to omega by c into square root of mu r epsilon r. Now mu r value has become 16 and epsilon r value has become 9, right? Okay, so substitute these values here. What you are going to get? Beta is equal to omega value is 2 pi into 10 to the power of 8 and c is nothing but what? C is nothing but 3 into 10 to the power of 8 and here square root of 16 into 9, you are going to get 4 into 3. Okay, so here 10 power 8 and here 10 power 8 will get cancelled and here 3 and here 3 will get cancelled. So therefore beta is equal to what? Beta is equal to 2 pi into 4, that is 8 pi radian per meter. So beta value has become 8 pi radian per meter, right? So now, so due to this heavy rain, okay, so due to this heavy rain, what happens? The medium properties has been changed. So because of this, beta is also going to change, right? So here beta value will become what? Will become 8 pi. So this is beta value in case of what? Rain. Okay, due to heavy rain, beta value has changed. Here in air medium, the value is 2 pi by 3. Because of heavy rain, what happens here? In that medium, the beta value has changed to 8 pi. Why it is changing? Because it is depending upon the medium properties, that is mu r and epsilon r values. So since these two are changing, beta value is also changing, right? Okay, okay. So 8 pi into z, 8 pi into z, ax cap volt per meter. Okay, okay. So this is the electric field expression. Next, H field, you have to write the expression for H field. So H field is equal to what? Is equal to, so here they are saying that assume amplitude of electric field remains same, but they are not saying amplitude of magnetic field will also remain same. They are not saying that. Okay, so which means you have to determine the amplitude of the magnetic field. So how we can determine the amplitude of the magnetic field here? We know that E by H ratio here. We know that E by H ratio is nothing but what? Intrinsic impedance of the medium, that is eta, right? Okay, so this is equal to what? So eta is nothing but eta naught into square root of mu r by epsilon r. Now what is electric field here? What is the amplitude of the electric field? The amplitude of the electric field is nothing but 120 pi, and the amplitude of H field you have to determine. We don't know the amplitude of the H field. Okay, so 120 pi divided by h is equal to what? So eta naught value here, eta naught value is nothing but what? 120 pi into square root of what? Mu r value. Mu r value has changed to what? 16. Yes or no? So mu r value has become 16. And what is epsilon r value here? Epsilon r value is nothing but 9. Understood? Now what you are going to get? Here 120 pi and here 120 pi will get cancelled. So therefore h is equal to what? H is equal to square root of 9 by 16, which is equal to 3 by 4, which is equal to 0.75. Right? So this is the amplitude of what? This is the amplitude of the magnetic field. Okay? Okay. So therefore I can write due to heavy rain, the amplitude of magnetic field has been changed. So what is the magnitude of amplitude of magnetic field? What we got? We got it as 0.75 into cos of what? Cos of frequency will remain same, that is 2 pi into 10 to the power of 80 minus. So in rain, due to heavy rain, beta value has also been changed. So what is the beta value we got? 8 pi. So 8 pi into z, 8 pi into z, ay cap volt per meter. So these are the expressions, these are the new expressions for electric field and magnetic field. Okay, so these are the new expressions for electric field and magnetic field we got. Right? Okay. Okay. Sorry, here for H field the units are nothing but ampere per meter here. The units are nothing but ampere per meter. Okay. Okay. So these are the some different types of problems in case of what? In case of lossless medium. Right. So in uniform plane waves we have solved some different types of problems for lossless medium, right? Okay. Okay. So with this I am winding up the session for today. So tomorrow here, so tomorrow we will see if they have given the expression for electric field, then how to write the expression for magnetic field. So these things we are going to see. So or else if they have given the expression for magnetic field, then how to represent, how to write the expression for electric field. So these things we are going to see in the tomorrow's session. So apart from this, we try to solve some more problems here in this uniform plane waves topic, right? Okay. Okay. So please share the session and like the session to as many students as possible here, right? Okay. Okay. See, depending upon your response, okay, we can bring some more new things to you, right? Okay. Okay, so with this I am winding up the session for today. So tomorrow we'll meet exactly at 7:30 p.m. Okay, so tomorrow our EMT class will be at 7:30 p.m. So it is only for EC students here. It's only for EC students, right? Okay. Selvaraj, as it is just the first class here, first class for EC students, right? Okay, so that's why I have started with I have started today itself with uniform plane waves, right? Okay. Okay, so that's why I have taken some basic problems so that you will get familiar with these problems, right? So you have to get familiar with these parameters, what intrinsic impedance, phase velocity, phase constant, all these things, right? So once you get familiar with these things, then we will move on to next level here, right? So since I have started today itself the uniform plane waves topic, I have taken very simple problems, right? Okay. Okay. right. So as we proceed here, as we proceed into the subject further, so I will take some more difficult level problems, right? Okay. Okay. Yes, I am planning to cover everything here. So uniform plane waves, once uniform plane waves completed, then we'll go for transmission lines. So and then I am planning for oblique incidence, problems based on oblique incidence topic. And then I am planning for waveguides also, waveguides and if possible antennas also, right? Okay. So it all depends upon your response here. See, today nobody is there in live, right? Okay. So if it goes like that, we are not going to get that motivation to cover all the topics, right? Okay. So your support is very much needed. So if you attend the live session, if more number of persons attend the live session, we will also get some motivation to teach. If nobody is present, means to whom we have to teach in live, right? Okay. So that will demotivate us. That will very much demotivate us, right? Okay. So if you support us, then we'll put some more efforts and we'll try to give our best to you, right? So your support is also needed here. Yes, past 3 months I am giving daily here. Past 3 months I am giving daily sessions on EMT. So maybe you are attending today, maybe, right? Maybe you are new. Already I have given many number of lectures on EMT, right? But I have not taken the topics exclusively for EC. So I have taken most of the topics which are common for EC, electrical and instrumentation, right? Okay. Okay. So anyway, please share the session and like the session to as many students as possible, so that we try to give you more number of different types of problems and the way of approach to solve those problems and the concepts behind those problems. Everything we will discuss, but we need your support here. So that's what I am asking for, right? Okay. Okay. So with this, I am winding up the session for today. So tomorrow we are going to start exactly at 7:30 p.m. here. The class is going to start exactly at 7:30 p.m. right? So okay guys. So okay then. Take care. Bye bye.